What is calculus? Let me just try to give you a bird's eye view of what calculus is trying to accomplish, just so you have an idea of what you're trying to do and learn when you study calculus. Calculus is our way to try to understand functions from the real numbers to the real numbers. And a function is just a correspondence to every real number x. We assign a real number f of x, and now we're trying to understand the properties of this function, of this correspondence. For example, some of the basic functions we study are f of x equals x, or f of x equals x squared, 2 to the x, or some of the trigonometric functions. But of course, the goal is to study much more complicated functions, such as the value of the stock market over time. And you see that to understand a function, it is very useful to draw the graph of the function. And to draw a graph, for every value a, we find f of a, and we draw a point at a comma f of a. And that gives us a sense of all the values of the function f. Some functions are easy to graph because their behavior is easy to describe and understand. For example, this is the function f of x equals x squared and its graph. But not every function is easy to graph because for some functions, it's hard to tell what's happening at certain points. For example, for these two functions, it is difficult to tell what is actually happening as x gets closer and closer to 0. And that brings us to the first and perhaps the most fundamental concept in calculus, which is that of a limit, which tells us what happens to the values of a function as I approach some particular value of x. So for example, for 1 over x, as I approach 0 from the right, I get to infinity, but when I approach 0 from the left, the values go to minus infinity. As another example, for the function sine of x over x, as I approach 0, regardless if I approach from the left or from the right, the value that I get is exactly equal to 1. And if you graph the function, you see that that is the case. As I approach a value of 0, the values of the function approach the value 1. Some functions are nice and connected. You can sort of like trace the graph with your finger, but then sometimes there is a jump, and we call that a discontinuity, which can be detected using limits. For example, the function that is x divided by its own absolute value, except at 0, has a discontinuity at 0. This is the graph. It is equal to minus 1 when x is negative, is equal to 1 when x is positive. So no matter how you define the function at 0, there is going to be a jump at discontinuity. For example, the function sine of x over x, it is not defined at 0, but if I define the value to be 1 at 0, then it is a perfectly nice continuous function whose graph I can trace with my finger. So continuity is another big theme in calculus. Another important question to answer about functions is how fast are values changing? For example, if the function is the position of a car, then how fast the value is changing of the position will give me the velocity. So I want to know how is the function changing, which means in terms of the graph, how steep is the graph at certain points. Another related question is for what values of x the values of the function are increasing versus decreasing. And well, you can see that if the function is nice and smooth, the places where there will be a change from increasing to decreasing have to do with when the tangent lines are parallel to the x-axis. So one big goal of calculus is trying to determine the tangent lines at any given point of the graph. And to determine the tangent line, the first thing we need to know is what is the slope? How steep is that tangent line? And precisely what we call the derivative of the function at a point gives me that slope of the tangent line. And formally, we actually define the derivative, the slope of the tangent line, as a limit. Finally, for a variety of reasons that you can imagine, we want to compute areas, to be able to compute the area of a region that is limited by graphs of functions. For example, the graph of this function is half of circumference of the circle of radius 1. And that is exactly what an integral is, which is another of the fundamental concepts in calculus, but it's simply just the area under a graph. And finally, there is this beautiful result called the fundamental theorem of calculus that tells you that integrals and derivatives are related. It tells you that the area under the graph can be computed as the values of another function whose derivative is little f.